Today in section 4 of chapter 7, we're going to be looking at similarity in right triangles. So being more specific, yesterday we were working with any kind of triangle, and we were looking at pairs of triangles. Today we're going to be looking at one right triangle and then having it cut into two smaller triangles so that we can use those relationships of those similar right triangles. So in your interactive notebook, if you are looking at that piece glued in, it says if the altitude is drawn to the hypotenuse of a right triangle, then on the left side you have this first one that we're going to look at. Each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So if you open up that top piece, you're going to see the formula. Okay, so this is that second piece that you see. Because it's talking about the leg being the geometric mean. When they talk about the geometric mean, they're just saying that leg, since the leg is the geometric mean, okay, that leg shows up twice in your formula. Okay, it's going to be opposite of one another. When you cross multiply, you'll be multiplying it by itself or squaring it. Okay. So when we look at this diagram, we have a right triangle. This great big triangle is a right triangle. The altitude has been drawn. The altitude goes from the right angle and is perpendicular to the hypotenuse, which means then it forms two other right triangles. Okay. These right triangles, all three of them, the great big one and the two small ones, are all similar to each other. So because of that, we can use this proportion to be able to solve for a missing piece. So on the left-hand side, if you open that flap, it says to find, actually we want to do the right side. We're going to find the length of y, which is one of the legs. So we need to plug in this information. We're setting up a proportion, two fractions equal to each other. Okay. So we start out wanting the whole hypotenuse. What is the length of the hypotenuse of this right triangle? 25, because we have to add those two parts together. Okay. The length of the leg is what we are trying to find. So that is y. And then the part of the hypotenuse that is next to the leg is the 9. Okay, because we're looking for leg y. It is next to the 9. So now we have our proportion. We're going to cross multiply and solve. So 25 times 9 is 225 equals y times y is how much? Y times y is how much?
Y squared.
Y squared. Okay, y plus y is 2y. Y times y is y squared. So I want y, which means I have to take the square root of both sides. What is the square root of 225?
I don't know.
15. Okay? If you do not know your perfect squares, this lesson will be a challenge for you. Okay? That is why we have you learn your perfect squares, because they are used often. So that is one of the types of proportions that can be set up. On the other side, it says if the altitude is drawn to the hypotenuse of a right triangle, then the length of the altitude is the geometric mean between the two segments of the hypotenuse. So this time the altitude is the geometric mean, which again means that that altitude number shows up twice. So I'm setting up a proportion. If you look at the formula that we have part of the hypotenuse, and then opposite of it, we have the other part of the hypotenuse. Okay? So it doesn't matter which one you put where. We're using both of them. And because of their location, they're being multiplied together. Okay? So it doesn't matter where you put the 9 and which one you put the 16. The altitude is what we're looking for. So that's our proportion. So we're going to cross multiply. 144 is equal to x squared. So I take the square root of both sides. What's the square root of 144? 12. So x is equal to 12. So when we have any type of right triangle with the altitude drawn, we have two different formulas that we are able to use. Okay? You just need to look at what you're given and what you're looking for to determine which of those two formulas you are going to be able to use. So if you turn your page in your interactive notebook, we have the similar right triangles practice. Some more problems we're going to go through. So let's take a look at some examples. This first example, okay, I see my variable x here. Okay, what is that identifying piece? When you look at your formulas, we have legs, we have altitudes, we have hypotenuse, parts of hypotenuse. Okay, so this is a part of the hypotenuse. When you look at your two formulas, part of the hypotenuse is used in either of them. Okay, so we need to look at what else we have. Key pieces for these formulas is that altitude and a leg, because those are those geometric mean pieces. So when I look at my picture, which of those do I have? The altitude or the leg? Leg. I have the leg in 6. Okay? So that tells me which formula I need to use. So hypotenuse is how long? What I do to those pieces? I add them together. So x plus 3. Whoops. Okay. So x plus 3. My leg is 6. So that goes in both locations. The part of the hypotenuse by the leg is the 3. When I cross multiply, I need to distribute. So 3x plus 9 equals 36. So I subtract 9. 3x equals 27. Divide by 3. to find that x is equal to 9. In my next example, when I look at x, what part of my right triangle is x? It is a leg. So I am going to be using that same formula we used in the first one. What's the length of my hypotenuse? 12 over leg x equals leg x over the part next to the leg, which is 3. So I cross multiply. X squared equals 36. So I take the square root of both sides. X is equal to 6. Ian, can we sit up in our chair, please? Next example, we have both an x and a y, so we're going to be working two separate problems. If we take a look at the x first, what do I have? What part do I have when I'm looking at x? Okay, x is part of the hypotenuse, which again is in both formulas. Okay. So do I know the altitude? No, I don't know the altitude, so I can't use the altitude formula. So I'm going to use that leg formula like we did in the previous two. So what is the length of my hypotenuse? 8 plus x. The leg is 10. And the part of the hypotenuse next to the leg is leg of 10. So you have to use the 8. So distribute when you cross multiply. 64 plus 8x equals 100. So I subtract 64. 8x equals 36. Divide by 8. X is 8 goes into 36 4 times is 32, so we have 4 left over, 4/8, which is 1/2. So x is 4.5. Now I also need to find y. When I look at y, what part of my right triangle is y? Y is another leg, so same formula again. So what is the length of my hypotenuse? We know what x is now, though. Okay, we can't use the x because we're going to solve for y. So what is my hypotenuse?
36.
8 plus x. 8 plus 4.5 is 12.5. So 12.5 over y equals y over 4.5. So when I cross multiply y squared, I'm going to save time. 12.5 times 4.5 is 56.25. Okay. Square root of both sides. Gonna have to do a factor tree unless somebody knows the square root of 56.25. So what are factors of 56.25?
.25.
I would actually do 25. That's 2.25. What can I do to factor 25? 5 and 5. What can I do? If I take my decimal out, what's the 15? So it's going to be 1.5. Okay. So I have a pair of 5s and I have a pair of 1.5. And 5 times 1.5 is 7.5. So y equals 7.5. Next one, we're going to start out by finding x. What part of my right triangle is x?
Leg.
It's the leg. So we're using that formula again. What is my hypotenuse? Y plus 6. My leg is x. Part of the hypotenuse closest or next to the leg would be the 6. But I have a problem here because I have 2 different variables in that equation. Cannot solve with 2 different variables. So we're going to leave that alone for now, and we're going to take a look at y and see if we can find y. So what part of my right triangle is y? It's part of the hypotenuse, which again uses both formulas. Do I know the altitude?
Yes.
I do know the altitude. Okay? I do not know a leg, okay? Because that's where my x is. So I'm going to use this other formula that uses the altitude. So I have my parts of the hypotenuse, which is the y and the 6. Doesn't matter where they go. And then the altitude is the 8 and 8. So 6y equals 64, which means y equals 10 2/3. Okay? Cannot use a decimal because you'll have an error. Okay? It's not an ending decimal. So you need to use your fraction. So now that we know what y is, we can go back up to our x formula because we're going to put the 10 2/3 in here. Okay, so now my hypotenuse is 16 2/3 over x equals x over 6. X times x is x squared. 16 2/3. Okay. If I change that back to an improper fraction, 16 times 3 is 48, plus 2 is 50. So I have 50/3 times 6, which is 6 over 1. So 50 times 2 is 100. Which means x is equal to 10. Next example. Let's see if we can find x. Are we going to use the altitude or the leg formula to find x? We're going to use the leg formula because that's what we're looking for. How long is my hypotenuse? 16. Remember, we add the pieces together. So 16 over x equals x over the part next to the leg, which is the 5. So x squared equals 80. Okay. Is 80 a perfect square? No, it is not. So we need to do factor tree or perfect square method. What can I do to factor 80? 10 and 8. What can I do to factor 10? 2 and 5. Those are done. How about 8? 2 and 4. What about 4? 2 and 2. So I have 4 2s and a 5. If I have a pair, 1 comes out. Pair, 1 comes out. So it is 4 square root of 5 for x. Now I need to find y. What part of my right triangle is y? The altitude. So I'm going to use the other formula. That one uses both parts of the hypotenuse. So 5 and 11. And then the altitude is the y. So I cross multiply. Y squared equals 55. Is 55 a perfect square?
No.
No? What can I do to factor 55? 11 and 5. Can I factor either one of them?
No.
No. Okay, so my answer is square root of 55. Next one. Looking for x. Okay, guys in the back, let's pay attention, please. Okay. Which formula am I going to use? Altitude or leg? Going to use leg because I know the leg, I don't know the altitude. So my hypotenuse is how much? 1 plus x over the leg 3 equals leg 3 over part of the hypotenuse next to the leg, which is the 1. So x plus 1 equals 9, which means x equals 8. Now, when I look for y, which formula am I going to use? The altitude, because that's what y is. Y is the altitude. So I use my 2 parts of the hypotenuse, 1 and 8, and then my altitude, y and y. So y squared equals 8. So I take the square root of both sides. What's the square root of 8? What can I do to 2 and 4, 2 and 2. So I have 1 pair of 2s. So a 2 comes out. The other one is left in. 2 square root of 2. Last example. This one's got 3 pieces. To find x, which formula will I use? Leg or altitude? Leg. So my hypotenuse is x plus 3 over 6 equals 6 over part adjacent, which is 3. So 3x plus 9 equals 36. So 3x equals 27, which means x equals 9. When we look for y, which formula are we going to use? Leg again. So hypotenuse, how long is my hypotenuse now? 12 over y equals y over what parts? 9. So y squared equals 108. Is 108 a perfect square? No. What's a perfect, or what can we do to factor 108? 9 and 12, I heard. What can I do for 9? 3 and 3. What about 12? 3 and 4. 2 and 2. So I've got a pair of 3s, I've got a pair of 2s, and then I've got the leftover 3. Okay, so 6 square root of 3 is y.
Z.
And now I need to find z. What am I going to use to find z? Altitude. So we need the two parts of the hypotenuse, 3 and 9. My altitude, z. Z squared equals 27. So I take the square root of both sides. So factors of 27. 9 and 3. 3 and 3. So I've got a pair of 3s. So 3 square root of 3 is that one. Okay. So 2 formulas. You just need to look at your information to determine which of those 2 formulas you are able to use.